Alright guys, today I'm going to show you this generator accessory power distribution box, spider box, whatever you want to call it. I originally made a box like this, similar to this, for a 120 volt 3500 watt generator that I bought last winter. I have since upgraded to a 7600 watt 240 volt generator, and originally I was going to buy a generator that did not have a power meter on it. And I wanted a power meter that would show my total consumption that I'm drawing from the generator. And so I was going to build this box with some meters just to keep my eye on, line 1 and line 2 of the 240 volt. You got two hots, that makes 240 volts. So 120 here, 120 here. So if you look at this box, everything down the center here is 120 volt line 1, and everything down here is 120 volt line 2. And like I said, the main reason was to have the power meters, and this does allow me to have the generator pushed a ways back into the woods, and I can run a cord up to it. It's the cord is 10 gauge 10-4 SO cord with a 240 volt 30 amp twist lock plug on it. Now, just for the video today, I'm going to be using an adapter that I made that goes from a regular 120 volt outlet just to demonstrate this box. And so when I'm demonstrating it tonight on that adapter, and you're looking at these two power meters, the incoming power, the voltage and the hertz on both of these should be the same. But then these two outlets are connected to this meter, and these two outlets are connected to this meter, so anything drawing off of these outlets would be different depending on what's plugged into which outlet. And of course, this 20 amp breaker is for this outlet, this one's for this one, and so on and so forth. Of course, down here on the bottom, I've got it's actually like a strain relief. It is a strain relief, but it also is like a locking. When you tighten up the nut here, there's some teeth that bite into the rubber sheeting on this SO cord, so the cord doesn't pull out. It gives a nice strain relief. One of the benefits of this box is that it only has, if I can show you here, it only has about 15 feet of cable on it. So you could plug this into your generator and it only gets you 15 feet away. However, I do have generator extension cords. I have several 25 foot, I think I actually have 3 or 4 25 foot 10 gauge 4-wire extension cord, so I can get this up to 100 feet away from the generator. So I could plug, I guess what I'm getting at is I could plug this into the generator, and then out the top of this box, I can take an extension cord and plug into here, 25, 50, 75 feet, and I can plug that into my inlet box in the back of my house and feed my transfer switch. Or I could put 75 feet of cord in front of this box. I could plug 50 or 75 feet of cord into the generator first and then plug this box in. I guess what I'm trying to get at is this box can be used at either end of the circuit. It can either be used at the generator end or at the opposite end of the extension cord. These meters will meter everything that goes through these outlets and through this plug. So if I want to plug my inlet box to feed my transfer switch in my house, these meters will show what my house is drawing. Let me get this plugged in and I'll show you how the meters work. Okay, so just to be clear, like I said before, these breakers are for these outlets, these GFI outlets. These breakers are not connected to this outlet leaving the box, but these gauges are. So these gauges will read anything plugged in here or down the line from that outlet on the top of the box. This switch is a double pole, single throw switch. So instead of having two individual switches, one for each gauge, it's basically two switches in the body of one switch. So one switch turns both meters on. I don't know if you can see that. All right, I killed some of the light and zoomed in a little closer. Hopefully that'll help you see the meters a little bit better. Anyway, like I said, I'm running off that adapter. So both of these gauges will probably read pretty much exactly the same voltage and the exact same hertz. unless there's some variances within the meters themselves, which I wouldn't doubt. They're not very expensive meters, so I don't think that they're super highly accurate, but they give you a real good ballpark. And so just to demonstrate, each one of these is a 20 amp GFI outlet. You can test. Red light comes on, reset, test, reset. And I've got testers here. It's a GFI tester and circuit tester. Both lights come on. That means it's good. Hit the button to test the GFI. Everything works like it should that way. These particular outlets have real tight pin fitment, I guess you'd call it, which is nice. Which is nice. I've got an electric heater over here. If you can see this, I've got an electric heater over here, and I'm going to plug it into one of these and test. So this would be line 1. Anything on this side of the meter is line 1. Anything over here is line 2. And so we can look at the amp draw and the wattage. It's funny that the watts don't start at 0. That must be what the gauge itself draws, because I have nothing turned on or feeding down line from these gauges. So, but let's turn on this heater. I will turn on just the fan first of all, and you can see that that's 0.22 amps, 22 watts. Now if I turn it on to the first section of heat, that's 750 watts worth of heat. You see it doesn't quite go to 750, it's 726. 6.09 amps. And we're at still 119 volts. Now this is plugged into the wall outlet at the house, so we're not testing a generator here at this point. I'm just demonstrating the meter. And if I go to high on the heater, should go to 1500. Goes to 1320. Now if I turn this off and I unplug it from here, plug it into this side, or I can plug it into any one of these, doesn't matter. We'll go to fan first. 0.2 of an amp. 21 watts. Still 122 volts. We're going to go to low on the heat, which should be 750 watts. Just like the other one, it didn't quite draw 750. And now if we go to high on the heater, should be 1500 watts. And just like the other one, it didn't draw quite the full 15. But you can see it's drawn 1330 watts, which is about 11.5 amps. We're still at 60 hertz, 59.9, 60 hertz at 115 volts. So turn it off. And like I said, originally I wasn't even planning on building a box like this, but I had planned on buying a generator from the Nationwide Tools Store company, which was their 9,500 watt inverter generator that did not have any gauges on it. Well, I ended up going with the GENMAX 9000 watt inverter, which does have a gauge on it. But by the time I decided to buy that generator, I'd already started collecting parts and pieces for this box. And if anybody's interested, I will kill the power and take the top off and show you the inside. Give me 1 second. Okay, so just for fun, we're going to take a quick look on the inside here. I'll loosen these screws up. When I made this box, I completely drew the panel and all the openings in Inkscape, which is an Illustrator program, not a CAD program, but I'm more familiar with Inkscape, so I use that. And it's very similar to Adobe Illustrator. It's the cheap, free version, Inkscape. And then I printed it on sticky back paper and glued it Well, just stuck it to the face of the panel here, and then I was able to cut everything out and drilled all my holes, everything. I got it drawn out perfectly, got it drilled out perfectly. I nailed everything the first time. There's nothing off. It turned out perfect. All right, let's lift the cover off. Let me get the light turned back on. Anyway, as you can see, everything's pretty much color-coded. All the blacks for line 1, all the reds for line 2. All the terminals were non-insulated and then heat shrunk with the adhesive-lined heat shrink tubing. The 2 gauges come right off of main line power, but they do immediately run through, if you can see this right here, they do immediately run through. Each gauge has its own 3 amp fuse, and all the connections were made with, this is all 10 gauge wire, and all the connections were made with some blue wire nut caps. First of all, the joint was twisted tight with alignment pliers, then the excess copper was cut down, the wire nut was threaded on tight and tightened with alignment pliers, and then taped on, and then the tape was held on with a zip tie. And I know electricians get offended about using accessory tape, but I don't care, because believe it or not, and some electricians will tell you that's not true, but believe it or not, some electricians do use accessory tape. Anyway, you can see its basic circuitry. Like I said, each gauge has its own, I don't know if you can see that, double pole, single throw switch. So each gauge is fed with its own power wire, one from each hot, and then you got your current transformers down here feeding the gauges, and then the power wires are fused. Each one of these breakers, 20 amp for 20 amp outlets, and then of course you got the feed through outlet up on top here to continue on with power down the line. I've put a handle on each side, and some people might be wondering what these chrome bars are for up on top here. And honestly, I can't take credit for that. When I was searching online for something, I forget what it was, a picture had popped up of a control box for some sort of an automated machine, factory machine or something. And the box had these chrome bars on it. Well, turns out that it works real good, so if the box goes upside down, none of that stuff, that switch, the gauge, the outlets, nothing will hit the ground hard, and it protects the front of the box. I've got real nice rubber feet here on the bottom, and there are a couple of chrome bars up on top in case this box goes down on end. And lastly, I really contemplated even making this video. The last electrical accessory box I made, you know, a lot of people saw that video compared to the people who commented, and very few people made negative comments. And I just blows my mind that somebody could be offended about something that I built for me. You know, if you don't like this box, you don't like my design, you don't like my reason for making it, that's fine. I don't care. If you don't need one for your situation, then don't make one. I don't care. If you want to build a box that solves other sets of problems that I'm not dealing with, and you've got other needs for other things, then build a box that fits your needs. I don't care. Anyway, I took some heat in that last video. I contemplated even releasing this video, but we'll see how it goes. We'll see how it goes. Leave a comment and let me know how this would benefit you, or if you'd like one for yourself. I don't make them. I'm not in production for them. But, you know, if I had a want or a need for one of these, I'm sure other people would find a use for it too. Just let me know. Let me know what you think. That's all I got for now. Please be sure to like, share, and subscribe for more. Thanks for watching.